Welcome back to Physics 101. Today we'll be talking about forces and motion. Let's begin with kinematics. Kinematics is a study of motion itself, but not the forces that produce motion. Kema is the Greek word for motion. Dynamics is the study of forces that produce motion. Many people are confused with the topic that we're covering now. Scalar and vector quantities. A scalar quantity is a quantity that has magnitude, which means that it only deals with size. A vector quantity deals with both size and direction. Another topic in kinematics is position and displacement. Position deals with the distance of an object from a reference position, including the object's direction. Displacement, on the other hand, refers to the change in position of an object, including the object's direction. The last thing we're going to discuss in kinematics is speed and velocity. It is commonly confused that speed and velocity are the same. The difference between them is when finding average speed, you calculate the ratio of total distance traveled to the total time of travel. Whereas when finding average velocity, you calculate the ratio of the displacement to the time interval for the displacement. Now, I'm going to hand it over to Lucas to talk about the next concept in forces and motion.
Now we are going to talk about constant acceleration and acceleration due to gravity. Acceleration, to start, is the rate of change of velocity. It is a vector quantity. Constant acceleration is straight line motion in which speeds change by the same amount each second. Average acceleration is the change of velocity divided by the time interval for the change. This is also a vector quantity. Free falling is when an object is falling towards Earth's surface with no air resistance. The velocity of an object free falling in Earth's atmosphere will always be 9.8 meters per second squared. And now back to Bojo.
Hey Lucas, thanks for the paper. You know you're wasting trees. But on the third topic now, we're going to be dealing with forces and free body diagrams. Force deals with a push or pull, and it is a vector quantity. So now, let's begin with some forces that deal with objects. Gravity, the attraction between all objects. Applied force, the general name for any contact between objects. Normal force is the force at a right angle to objects in contact. Friction is the force between two objects in contact with each other. There are two types of friction. First one being static and the second one being kinetic friction. Static friction is the force that prevents a stationary object from starting to move. Kinetic, on the other hand, is the force that acts against an object's motion. There are two more forces that are commonly forgotten. First one being air resistance, which deals with friction on an object moving through air, and the second one, tension, which the force exerted by strings, ropes, fibers, and cables. There are two diagrams that we use in physics. First one being the system diagram, which is a drawing of all objects in a situation under analysis, and the second diagram, which we use more often, is the free body diagram, a drawing of just the object being analyzed with all forces acting upon it. Now let's go to Lucas for a live demonstration of a free body diagram.
The demonstration I'll perform is showing the forces acting on a human when running. Friction works backwards to the direction that the person is running in. The next is the normal force. This is the force that works 90 degrees onto the person's body. The applied force is the force that the person is using against the ground to push forward. Air resistance is the friction of the air pushing backwards onto the person. The last is gravity, which is the Earth's force that is working downwards onto the person's body.
Now we're going to briefly talk about inertia and Newton's first law of motion. Inertia is a property of matter that causes an object to resist changes in its state of motion. It is directly proportional to the mass of an object. Net force, on the other hand, deals with the vector sum of all forces acting up on an object. Newton's first law of motion states that if the net force acting on an object is zero, the object will maintain its state of rest or constant velocity. A good example of inertia is when you're driving a car. So when driving in the car and your body both move forward. So let's say somebody's driving and the driver brakes all of a sudden, your body would want to move forward, but the seatbelt prevents that from happening.
Now let's quickly talk about Newton's second law and weight. Newton's second law of motion is that if the external net force on an object is not zero, the object's acceleration is in the direction of the net force. The magnitude of the acceleration is directly proportional to the net force and inversely proportional to the object's mass. Now let's talk about the difference between weight and mass, which many people think are the same. Starting with weight, is the force of gravity on an object and is a vector quantity measured in newtons. Mass is the quantity of matter on an object and it is measured as a scalar quantity measured in kilograms.
Now, let's talk about Newton's third law of motion. For every force there is a reaction force, equal in magnitude but opposite in direction. If an action force is exerted by an object X on an object Y, then a reaction force is exerted by an object Y back on object X.
Now let's talk about simple machines. A machine is a device that helps us perform a task by achieving at least one of 5 main functions of a machine. These 5 functions are change in energy from one form to another, transfer of forces, change of direction of a force, change of magnitude of a force, and change of distance or speed. Now let's go through some parts of simple machines, starting with a lever, which is a rigid bar that can rotate freely around the fulcrum. A fulcrum is a support around which a lever can rotate or pivot. The effort force is a force applied onto one part of a lever to move a load at another part. A load force is the force exerted by the load on a lever. Effort arm is the perpendicular distance from the fulcrum to the effort force. The load arm is the perpendicular distance from the fulcrum to the load arm.
Now going to torque and levers. Starting with torque. Torque is the turning effect caused by a force on a rigid object around an axis or a fulcrum. It is measured in Newton meters. Now, the law of the lever. When a lever is in a static equilibrium, the magnitude of the effort torque equals the magnitude of the load torque.
The last thing we're going to be talking about in our video today is mechanical advantage and efficiency. The ideal mechanical advantage is the ratio of the effort force arm to the load arm for a machine. Now, for a machine to be efficient, you want its actual mechanical advantage to be high. This is calculated by the ratio of the load force to the effort force for a machine.